Hello everyone, welcome to the new section on pressure. Now previously you have covered this formula P equals F over A. And let's recap a few more formulas that you have learned previously. Under the topic on mass, weight and density, you also have covered weight equals mass times gravitational field strength. And you also have covered density equals mass over volume. Now let's park that one side. So the question for this part is, if you're familiar with pressure equals force over area, so for this particular object, if this is actually a box, what you're interested in is this area and the weight of the box, right? So the weight of the box and the area. So from here, in order to calculate the pressure that the box exerts on the area on which it's lying on, so you get pressure equals weight over area. Now the question is, what happens if the box is actually a container filled with liquid? So now this liquid takes the form of the box it's contained in, hence you see a rectangular shape. So what if it's a liquid? Can the solution be further simplified? Of course the answer is yes, otherwise I won't be asking this question. You want to further simplify it because technically it is going to be very tedious to measure the weight of the liquid, especially if it's a large water tank. Like example, a swimming pool. You you don't want to go and measure the weight of the water in the swimming pool. You want to simplify any form of calculation. So for this section here, I'm going to show you how to simplify the calculation. First, from pressure equals force over area, since weight is a specific example of force, we have pressure equals weight over area. Now, earlier on, you have also covered weight equals mg, and you also covered density equals mass over volume. Now, we are going to put all these three together to derive an inverse simpler formula. So we're going to start with density equals mass over volume. Now, before we proceed, let's go back to the diagram and try to add on some more measurements. The area I've highlighted in red is the area that the shape is resting on. Now let's add on one more thing. Let this be the height of the structure, of the liquid, So that means we have volume equals base area times height. And that means density equals mass over area times height. And since weight equals mg, I have a m over there, so I'm going to express mass in terms of density, and I'm going to have mass equals rho a h. Rho refers to the density, if you cannot remember. And I'm going to sub that formula into W equals mg, so I have weight equals rho a h g. Don't panic, it looks like it's getting longer, but trust me, it's getting simpler. So you look back at the very first equation, pressure equals weight over area. Now I'm going to substitute the weight formula into W over A. So I have P equals rho AH G over A. And now I have rho H G, but it's commonly written as H rho G. So P equals H rho G. This is something new for you all. So what exactly is P equals H rho G? Let's rewrite again. P equals H rho G, where P refers to liquid pressure at depth H. Okay, that's liquid pressure at depth H. And the unit is, the SI unit is Newton per meter square or Pascal. Now, when we solve problems using P equals H rho G, unfortunately, we have to convert everything to SI unit. I'll explain further what I meant by that. Okay, H refers to the vertical height of liquid column, and the SI unit is meters. Note the emphasis on this word, vertical height. So when I mention vertical height, it means it has to be perpendicular to the surface. The base, it has to be perpendicular to the base. Rho refers to the density of liquid, and the SI unit is kilogram per meter cube, and G refers to the gravitational field strength, and it's Newton per kilogram. Now, usually, or should I say most of the time, your gravitational field strength is expressed in terms of its SI unit. Now, because of that, your vertical height and your density has to be expressed in SI unit, and therefore your liquid pressure has to be expressed in SI unit. Now for your G value, sometimes you're given acceleration due to gravity. Well, you can use that value because the acceleration due to gravity and gravitational field strength have the same magnitude. But because in this particular question, we are dealing with gravitational field strength, not motion. Therefore, I express G as gravitational field strength. So this is the new formula. P equals H rho G. Right, and P, H, rho, G, these are what it represents. So next, we are going to discuss how this actually works. Now, over here, the diagram you have shown, what you have is different tubes of different shapes and sizes. They're connected to the same base, so the pressure in the liquid at the same vertical height will always be the same. Now, when you pour liquid, whichever tube you pour in, you can pour in here, or you can pour in here. The liquid will all rise to the same vertical height. So in a way, we say that the liquid will always try to find their own level. That's because the four surfaces all experience the same atmospheric pressure. Hence, they occupy the same vertical height. We can also say that, sorry, should I use the word base? The bottom of each tube all experience both liquid and both the same liquid and atmospheric pressure. Hence, all have the same vertical height. So for now, that'll be all. In the next video, we're going to discuss some problem sums using P equals H rho G.